students, how are you? In the previous class, we have learnt about the dielectrics and the capacitance of a capacitor with dielectric slab, or you can say non-conducting slab between the plates. Today's topic is capacitance of a capacitor filled partially with conducting slab. This is your conducting slab, or you can say conductor, and inside the conductor electric field is always equal to 0. The thickness of the conducting slab is T and D is the distance between the plates. A is the area of cross section of each plates. Now the potential difference between the plates. Potential difference between the plates. Suppose its value is V. What is the relation between V, distance between the plates, and the electric field? You know, V is equal to E multiplied by D. This is your electric field and this is the separation between the plates. Now in air, what is the distance? Distance D is in air, T is in conducting slab. Therefore, the distance in air only, that is equal to D minus T, and in air electric field is E naught. That means the medium is air or vacuum. Now we can write here E naught, this is your electric field, and the distance is here D minus T. Suppose electric field inside the conducting slab, that is your E, and the distance is T, E into T. This term is equal to 0 because E is equal to 0 inside the conducting slab. Therefore, V is equal to E naught D minus T plus 0 you can write here, and within the bracket E is equal to 0 inside conducting slab. Inside conducting slab, inside the conductor, electric field is always equal to 0 inside the conducting slab. The value of the electric field is always equal to 0. Now this term becomes equal to 0. Then what is the value of V? V comes out to be E naught D minus T, and E naught can be written as, you know it, the between the plates sigma upon epsilon naught, because E naught means electric field in the air or vacuum. Therefore, we have taken here epsilon naught. D minus T. What is epsilon naught? What is sigma? Sigma is the surface charge density. That means charge divided by area. Now, the value of the sigma is surface charge density. Suppose on each plate in magnitude charge is Q. You can write here Q upon area. Area means area of each plate, that is equal to A epsilon naught D minus T. This is the value of the potential difference between the plates. Now, you know the relation between the capacitance and the potential. C is equal to Q upon V by the definition of the capacitance. Now substitute the value of V from this expression into this expression. We get here Q divided by Q upon A epsilon naught within bracket D minus T. Now A epsilon naught comes in the numerator. This implies that C is equal to Q A epsilon naught divided by Q D minus T. Q cancels out. We get here C is equal to A epsilon naught upon D minus T. This is the value of the capacitance when a conducting slab of thickness T is placed between the plates. Once again, the potential difference between the plates, how can you calculate? We can calculate the potential difference between the plates when the medium is air, the potential difference between the plates when there is the conducting slab. Now what is the distance in air? This is d in air and t is in conducting slab. The distance which is remaining in air only, that is your d minus t. And in air the electric field is E naught. E naught represents the electric field when the between the plates there is vacuum or air. Now the relation between the potential difference and the electric field and the distance between the plate is V is equal to E into distance. Therefore, in this case d minus t, electric field is E naught. In the conducting slab, suppose the electric field is E, thickness is T multiplied by T. But this terms becomes equal to 0. Why this term is equal to 0? Because the inside the conducting slab no electric field exists, equal to 0. Now if this terms becomes equal to 0, we get here V is equal to E naught d minus t. Now E naught is equal to sigma upon epsilon naught. Between the two parallel plates the electric field is uniform and its value is given by sigma upon epsilon naught. What is sigma? Surface charge density. That means charge divided by area. This is your Q upon A. This is the value of the potential difference between the plates. And what is the value of the capacitance? C is equal to Q upon V. Substitute the value of V from this in this expression. You will get here A epsilon naught comes in the numerator and Q cancels out. We get C is equal to A epsilon naught d minus t. This is the equation for the capacitance of the capacitor when it is filled partially with the conducting slab. When it is completely filled with the conducting slab, that means when T becomes equal to D, then C is equal to what becomes A epsilon naught upon D minus D. D minus D means 0. A epsilon naught divided by 0, this becomes infinite. Then the capacitance of the capacitors becomes infinite when a conducting slab is completely filled between the plates. That means a conducting slab of thickness D is inserted between the plates, where D is the distance between the plates. When these two becomes equal to each other, C comes out to be infinity. And this is the topic, capacitance of the capacitor filled with conducting slab. Now there are two questions. These questions are very, very important. And these questions, 3 parts comes in the board examination. Justification is also asked in these questions, and the marks of the question is always equal to 3. If 1 parts come, it is of 1 marks. 2 parts come, it is of 2 marks. Otherwise, it may also come in multiple choice questions. Now the question is, the battery remain connected to a parallel plate capacitor and a dielectric slab is inserted between the plates. Dielectric slab, now thickness is not given. We will assume that between the plates the space that is equal to the distance D is fully occupied by the dielectric slab. In other words, you can say thickness of the dielectric slab is D, because it is not mentioned here partially. What will be the effect on capacitance, charge, potential difference, electric field, energy density? Justify your answer in each case. We have to given the justification by using the formula only. Now the first word, which is very, very important, battery remain connected. In the second question, battery is removed, or you can say disconnected. You have to first observe which type of question is given in the board examination. If this type of is given, battery remain connected or without disconnected, both are the same things, or without disconnected, that means remains connected, disconnected. Now in this case your potential difference is equal to constant. When there is no dielectric slab, suppose the potential difference is V naught, and when dielectric slab is inserted, suppose potential difference is V, then V and V naught are equal to each other. Now we will write here as the battery remains connected, that means V is equal to constant. You can say here V is equal to V naught when there is vacuum or air between the plates, and V when there is dielectric slab between the plates. Now the first part is capacitance. Suppose now the capacitance becomes C, and you know what is the relation between C and C naught when the dielectric slab is inserted between the plates. That is K is the dielectric constant of dielectric slab. C epsilon naught A upon D. This is the relation which we have derived previously. Now what is this one? This is the capacitance of the capacitor when there is no dielectric slab, when the medium is vacuum or free space, you can say. Then you can write here C is equal to Kc naught. This is when no dielectric slab is placed. This is when dielectric slab is placed, and you know the value of the dielectric constant is always greater than 1. This implies that C becomes how many times? C becomes K times of original capacitance. This is your first answer. Now the second answer is, now we have to write the third answer first. Potential difference. You can say potential difference, that is your V. So V is equal to V naught. You can say here constant. It does not change. Now the second one is, what is about the charge? You can say Q is equal to C to V. And in vacuum you know that Q naught is equal to C naught, V naught. How can we write here? C is equal to Kc naught. You can write here Kc naught. And what's about V? V is equal to V naught. This becomes equal to this one. And what is this one? Cv is equal to Q. C naught, V naught is equal to Q naught. That means this is equal to Kq naught. You can say Q is equal to Kq naught. This implies that Q becomes, Q increases, you can say also. How many times it becomes? It becomes K times of the original charge. Q becomes K times of original charge. Now once again I am explaining. The battery remains connected. That means when the battery remains connected, that means there is no change in the potential difference between the plates. Battery remains connected, V is equal to constant. V is equal to V naught. V naught means when the dielectric slab is not inserted, and V means when the dielectric slab is inserted. V is equal to constant. That means when dielectric plate is not inserted and one dielectric plate is inserted. In both the cases, the potential difference is constant, and V is equal to V dash. Now what's about C? Capacitance when the dielectric slab is inserted, that is equal to K epsilon naught A D. We had derived this formula previously. What is its value? Epsilon naught A upon D. This is equal to C naught. This implies that C becomes K times of the original capacitance, because the value of K is always greater than 1. Now the third one we have derived already. Now the second one is Q. What is the relation between Q, C and V? Q is equal to CV. Now substitute the value of C. This becomes equal to K C naught. And what's about V? V is equal to V naught. Substitute here. C naught V naught. That means Q naught. Q is equal to K Q naught. This implies that Q becomes K times of the original charge when the dielectric slab is not inserted between the plates. And this is what's about the electric field. What happens to the electric field? Now the electric field, you know, this is the general value. This is your which part? Fourth part. Electric field, suppose E naught is equal to sigma upon epsilon naught when the charge is Q naught. Now the electric field becomes, suppose, sigma dash upon epsilon. Why epsilon? Because a dielectric slab is inserted between the plates. What's about sigma dash? Surface charge density. That means charge divided by area. Now the charge is Q divided by area, that is your A. And what is the relation between epsilon and epsilon naught? You know epsilon is equal to K epsilon naught. Substitute this value. We get here K epsilon naught. And in the part 4, second part, we had derived here what about Q. Q is equal to, you know that K Q naught we have derived in the previous one, divided by A K epsilon naught. Now the K cancels out. This is equal to Q naught upon A epsilon naught. And you know this is your E naught. That means there is no change in the electric field when a dielectric slab is inserted between the plates. In other words, you can state this one also. V is equal to E is equal to V upon D. V is constant, D is constant. Therefore, E is also constant. This is also constant. That is equal to E naught. You can state in this manner also, but this is a most reasonable way to explain what will be the value of electric field. Now the fifth one is your energy density. Energy density. And energy density, you know, it is denoted by UE, and its value is half epsilon naught E square. This is the value. But in this case, here dielectric is introduced. Then in place of epsilon, it becomes epsilon naught epsilon. If you substitute the value here, half, what about epsilon? K epsilon naught. And what about E? That means E naught ka square. That means now K comes outside the terms and we get here half epsilon naught E naught square. And this is the energy density when no dielectric slab is inserted between the plates. You can say K U E naught. And what is the relation here? Relation becomes here that the value becomes U is equal to K times U E naught. And the energy density increases, you can say also you can say becomes K times of original energy density. If you know that it is possible only the solution of all these parts, if you know when battery remains connected, that means V is equal to constant. This point is very, very important. Now in the second question, if the battery is removed after charging, now battery is removed, V is not constant here. Which term is constant when the battery is removed? Your charge is constant. In this case, as battery is removed, this implies that Q is equal to constant. That means Q is equal to Q naught. There is no change in the charge. This is the answer of second part. And the first one is capacitance. what will be the value of the capacitance. Now the first part is capacitance, you know, as in the previous question, C is equal to K due to the dielectric slab, epsilon naught A upon D, and this value is C naught, K C naught. That means C becomes how many times? C becomes K times of original capacitance. Original capacitance. This is your first part answer. Now what about the potential difference? Third part, second part answer is this one. Third part answer is, you know, what is the relation between C, Q, V? Q is equal to C into V. This is the relation. That means V is equal to Q upon C. And what is Q? Q is equal to Q naught. What is C? C is equal to K C naught. And what is this value? Q naught upon C naught. That is equal to V naught upon K. You can say V is equal to V naught upon K. Now, आपका V becomes how many times? Or you can say decreases 1 upon K times of original potential difference. Original potential difference का कितना times? K times. Once again, as the battery is removed, when the battery is removed, Q is equal to constant. Q is the charge when dielectric slab is inserted between the plates, and Q naught is the charge when no dielectric slab is inserted. In this case, both charges are the same. Now the first part is what's about capacitance. Then C is equal to K epsilon naught A upon D, and what is its value? It is C naught, the capacitance when there is vacuum or free space between the plates. So C is equal to Kc naught, and you know the value of K is always greater than 1. Therefore, C becomes how many times? K times of original capacitance. Q is equal to Cv, and what's about V? V is equal to Q upon C. Now the Q is equal to Q naught. We have substitute here Q naught divided by C. C, what's value of C? C is equal to Kc naught. Right here Kc naught. What is Q naught upon C naught? That is equal to V naught, original, when no dielectric slab is inserted between the plates. V naught upon K. So what is the relation between these two? That means now the potential difference becomes 1 upon K times, or in the words you can say decreases. The value of the potential difference decreases when the dielectric slab is inserted between the plates. Now the next one is here electric field and then energy density. What is the electric field? Now you know electric field E is equal to, we can write here electric field, this is your fourth part. Electric field E is equal to, in the previous case also, sigma dash upon epsilon. And what is the sigma dash? That is equal to charge divided by area. And what is epsilon? You know K epsilon naught. But what is the relation between Q and Q naught? That is equal to, it is Q naught divided by K A epsilon naught. And what is this one? This one is charge divided by area. That is equal to sigma 1 upon K. You can write here sigma upon epsilon naught. And its value is E naught. That means E naught upon K. You can say the electric field becomes how many times? E becomes 1 upon K times. When it decreases, you can see, becomes 1 upon K times of original electric field. Original electric field. Electric field. Electric field. If you write E decreases, it is also correct, but this is the reasoning why E decreases. Now the last one is energy density. Energy density, that is UE, and its formula is half epsilon naught in the case of the free space. In the case of the dielectric, you can write here epsilon E square. Now what is epsilon? You can write here K epsilon naught. And what is E? E की वैल्यू this one. That means E naught square divided by K square. Now K and K cancels out. We get here 1 upon K half epsilon naught E naught square. And what is this one? This one is the energy density when no dielectric slab is introduced between the plates. You can see here UE is equal to 1 upon K times UE naught. That means UE becomes, energy density becomes 1 upon K times of its original value. And you can say UE also decreases. Here E decreases, here UE decreases, but C increases. V also decreases. Okay, so these are the answers of these questions. These questions are very important for your board examination purposes. Now the next topic is common potential and loss of energy on sharing. These two topics are the last topic of this chapter. After that, this chapter will be ended. Now the topic is common potential. Common potential. Common potential means a potential which has the same value. Suppose you have two capacitors. Two capacitors are given to you and both have different